All right, hello everyone. I'm here today to run through Studio 7, which is about objects. So this was a very big moment for us in this semester. Objects are kind of what we've been working up to all semester long. In particular, we're talking about how to design objects. I know we can also talk about how to use objects, which is certainly something we'll discuss today as well. Um, but for each of these, we are given, a description of an object that we wish to create by defining a class for that object. And then, yeah, that's basically the whole studio. It's a lot less structured than some of the other studios we've done. A lot more wiggle room for you to, play around with these descriptions. But we are going to try and work through all of these today. So let's go ahead and dive right on in. We're going to start with one that we kind of saw in class, actually, when we reviewed this module in lecture. So let's go ahead and start with the rectangle. And we're going to make the class for it by right-clicking on the Studio 7 package, going to New Class, and we'll call it Rectangle. All right, and then, excuse me, we are going to examine this description. We can see actually this very first sentence has a very important phrase in it. It's called has a. So it says a rectangle has a length and a width. So by saying has a, that's a huge indication to us that these values, length and width, should ultimately become instance variables. And the way that we define instance variables for a class is by marking them as private. We always mark our instance variables as private. But then we need to choose a type for our instance variable. So I think for length and width, the type that would be most appropriate would probably be a double. And then we can give it a name, just like any other variable. So I'll call one length. Then I'll move down to the next line, make another one for the width. All right. The next thing that the description says is that a rectangle should be able to provide its area and perimeter. But before we get to that, I actually want to cover something that's not in the description that every class should have, which is a constructor. Remember from our discussion about this during lecture that the purpose of the constructor is to create an instance of a class. So this class defines a rectangle in very general terms. A constructor is used to create one specific rectangle. So in order to do that, we're going to create a method. Constructors are, in fact, methods. Constructors have the same name as the name of the class that we're in. And now we have to decide what parameters we want. For this one, we're going to say that whoever is creating the rectangle must tell us how big it's going to be with a length and a width. And we can do that by having two parameters called length and width. And now the way that the constructor creates an instance of this class is by ensuring that all of the instance variables contained within the class are properly set. So because we have two instance variables here, and we also have two parameters here, we just simply need to take these parameters and assign them to these instance variables. So I might try a statement like this. You may remember from the material that we went over for Module 7 that this actually is ambiguous, right? We actually have two variables called length. One of them is a parameter, and one of them is an instance variable. So when I type the word length, the computer has to make a choice. Which version of length am I referring to? Am I referring to this parameter, or am I referring to this instance variable? And we are, you can see that the computer has chosen the parameter, but the problem is that it's chosen the parameter to represent both sides of this equation, and so it's now kind of confused. It's saying, why are you just reassigning this variable to itself? That doesn't really make any sense. What we need to do is make sure that this one is actually pointing to our instance variable. And the way that we can do that is by using a special keyword called this. This represents the instance of the class that we are currently creating. So we're saying we want to take the length instance variable of this instance and set it to the length value that is being passed in as a parameter. And we'll use a similar statement to set the width. Oops. All right, at this point we have our constructor, so I think it might be good to go back and take a look at what else we're being asked to do as part of this rectangle. It says a rectangle should be able to provide its area and its perimeter. Now it might be tempting to store these as instance variables, but I would encourage you to think about the case that these actually don't need to be stored. They can be computed. So with that in mind, these I think are more like actions. I need to compute the area and compute the perimeter, and when I do so, I can use a method for that purpose. So we're going to define a method. We're going to define a method that returns a double, and we'll call it compute area, right? Now notice I'm not accepting any parameters here. I don't need any parameters. I'm going to rely on the instance variables. So by the time I get to this method, an instance of rectangle is already going to have to have been created. We cannot use this method unless this constructor has been called first to create an instance of the object. So our goal in this method is to compute the area for whatever instance this method has been called upon. And we can do that by referring to the instance variables. So once again, to compute the area, I'll just compute it as this times length, or this dot length times this dot width. That's how we compute the area of a rectangle, in fact. And once we return that value, specify that it is the output of this method, I believe this method is complete. And similarly, we'll see that for the perimeter, that's the other one that we're computing. It's going to look somewhat similar, where we just need to return this dot length times 2 plus this dot width times 2. Now, at this point in time, we're actually, at a place where we can test this. And in order to do that, I'm going to come down here and create a main method. Remember, a main method is the starting point of a program. So if you don't have a main method, then there's nowhere for your program to begin. So what do we want this main method to do? We want this main method to create a rectangle by calling the constructor and then, tell us what the area and the perimeter of that rectangle is. Let's go ahead and do that by making a rectangle variable. Notice that I'm using rectangle as the type here. That's because when we create a class, we're really defining a new type. So anywhere that, we've used a type in the past, we can now use rectangle as a type. That's interesting, right? Okay, so we'll call it R. We're going to call the constructor first by typing the new keyword, followed by the name of the constructor. Now we have to pass in some parameters. I'll make a rectangle with a length of 3 and a width of 4 just to keep, oops, I don't need those brackets. I need a semicolon there. I'll use some easy numbers here just so we can, easily check our results. And now we'll just tell the rectangle to compute the area, and we'll tell the rectangle also to compute the perimeter. Notice that in order to use these methods, I have to say instance name, which is this, the thing that was created by the constructor. Constructors create an instance of the rectangle class. And then I'm saying compute the area for whatever rectangle is in this instance right here. Compute the perimeter for whatever rectangle is in this instance right here. So let's go ahead and run this. We should see, hopefully, the proper answers come out. The area is 3 times 4, which is 12, and then the perimeter would be 6 plus 8, which is 14. Looks like we're on track. All right, let's see what else there is. A rectangle can indicate whether it is, in fact, a square. So one thing to consider here, I skipped a sentence, I'm sorry. A rectangle can indicate whether it is smaller than another rectangle in terms of area. So we want to have a way of comparing two rectangles, seeing whether it's bigger or smaller by area. And so again, I think this is a method. I think either a rectangle is going to be bigger or it's not going to be bigger. So to me, that suggests a return type of Boolean. And I might say, what does the description say? The description says a rectangle can indicate whether it is smaller. All right, so I'll say is, I'll name this method is smaller than. And so we want to compare two rectangles and determine which one is bigger, which one is smaller. A lot of times people will think, okay, in order to compare two rectangles, I need to take in, two rectangles here as parameters. Something like this. A couple interesting things to note here. First, note the type, right? Anywhere that we've used types before, we can now use the name of this class, because creating classes is like creating a type. So here's an example of that as the types of these parameters. But before we proceed, let's consider that we don't actually need both of these parameters here. again, in order to get to this method, we need to construct a rectangle using the constructor, and we can access whatever instance this method has been called upon using the this keyword. So we don't need to take two rectangles in because we already have one of the rectangles available to us via this. We're going to compare this rectangle to the rectangle that is passed in via parameters. So, all right, we want to do it by area. You could actually do this all in one line if you wanted to, but I'll split it up just to make things a little bit cleaner. I'll say Boolean is smaller is equal to this dot get area. Compute area less than R1 dot compute area. So I'm asking for R1 to tell me how big it is. I'm asking for this rectangle, the one upon which this method has been called, to say how big it is, and then we'll just compare the two. Finally, I can just return is smaller. If we want to test this out, we're going to come down here. We need to create a second rectangle upon which to compare. So I'll create another rectangle called R2, and I'll make this one bigger than the first one. So I'll make it 4, 5, which should be very much bigger. And now I want to do the comparison. I'll say system.out.println R dot is smaller than R2. So notice we can see the two rectangles very clearly now. Here's the first rectangle. That's going to represent this in this above computation. Here's the second rectangle coming in as the parameter. So since this rectangle is bigger, this rectangle is smaller than, I would expect this to print out true. Notice though that it is somewhat directional in the sense that you can swap the order, and this should now be false because this rectangle is not smaller than this rectangle. That should work out as well. There we go. Yeah. So that method also appears to be working. And now back to this one, we can say a rectangle can indicate whether it is in fact a square. So let's do one more method that's going to tell us whether it's a square or not. That's kind of similar to the last one in that either a rectangle is a square or it isn't. So public Boolean is square. I don't think we need any parameters for this one. We're examining this rectangle and determining if this rectangle is a square, which is pretty simple. We can just return this dot length is equal to this dot width. So if we want to test that, we can come down here and I'll make another third rectangle. I'll call it square. And I'll make both of these the same. So this is in fact a square. Now we can test this. We can test this on a square and we can test it on a not square. I'll say square dot is square. And then for this one I'll say R1 dot is square. I'm sorry, it's just R. There we go. So this one very clearly is a square. This one is not, so I would expect to see those results get printed accordingly. And there we go. That one's a square, and that one is not. I believe that's going to do it for our rectangle example. You can get into drawing and stuff if you want to, but we're going to move on to the next one. This one's actually pretty simple, pretty quick. We're going to make a die, as in one that we use for board games. So we're going to go ahead and create a new class. We'll call it die. What does a die have? What are the attributes? It's going to have n number of sides. So that, I believe, is the only instance variable, and it should be n excuse me, an integer. So I'll make an integer for the number of sides. The next thing I'm going to create, remember this one isn't in the description, but we're always going to create it anyhow since it's an important part of any class definition. We're going to create a constructor. I'll accept the number of sides that we want and store it in the instance variable, just like we saw on the previous example. No reason to mix it up. Worked last time. And I believe the only behavior that it wants is some way to throw the die. So we'll make a method called throw, and that's going to generate a random integer in the given range. So we'll go ahead and say public int throw. And for this one, we just need to use that little random number equation. We know we're going to have to cast it to an int, and then we can use math.random to give us a number between 0 and 1. we'll multiply that by the range. So if we are rolling a 6-sided die, for example, our number of sides would be 6, and I can multiply this by this number of sides. This is now going to get me a value between 0 and 5.999999 repeating, which if I then add 1 to that, I get a number between 1 and 6.99999 repeating. The integer here truncates that decimal, so I believe this should work for us. What am I missing? Oh. For some reason, I do not see. Oh, I see the problem. Throw is actually a keyword. Notice how it's in purple? I cannot use throw as a name of a method. That was a kind of a tricky one to figure out. I'll change it to roll. We'll roll the dice instead. Okay. To test this one out, we'll make a main method down here. And I'm going to write a little for loop to roll this die. Roll it 10 times because I want to make sure it's actually going to do things properly, but I need to make one first. We'll do one with 6 sides. I have to spell out the word 6. I can't use the number like that in a variable name, not as the first character anyway. And we'll say system.out.println 6 sides.roll. Here we go. Let's try it out. Let's see if this works. Hopefully we'll see all 6 numbers represented. There we go. 1, 2, 3, 4, 5, 6. They're all there. So it's possible to get all 6 of them. That's great. If I roll a 100-sided die, then we'll see much bigger numbers get generated, right? There we go. This looks good. Nice, short and sweet little object. Not a lot going on to this one. Pretty simple. Let's move on to our next one. The next one that we see here is called fraction. So let's go ahead and make a new class for our fraction. If we look at the description, it says fraction has a numerator and a denominator. All right. I believe those are going to be whole numbers, so we're not going to mess with fractions that have decimals. So I think, private int numerator and private int denominator are probably the most appropriate. We'll go ahead and make the constructor. I almost always do that immediately after I make my instance variables. We'll take the numerator and the denominator in as parameters and store them in the instance variables, just like we do for all other constructors. All right. Now we can return to the description and see what methods we need to be able to take care of. A fraction should be able to add itself to another fraction, returning a new fraction that represents the sum. Okay. So we wish to have a fraction that is going to add itself to another fraction. And just like we saw before, we are going to accept a fraction in as a parameter, but we're not going to accept 2 fractions because the second fraction is actually going to be this. But let's talk about the return type. If I add 2 fractions together, I get a brand new fraction as the result. So I'll go ahead and say that the return type is also going to be a fraction. And we're now ready to start doing the addition. Now, one thing that's kind of tricky for us as part of this problem, in order to add fractions together, we need to have the denominator be equal, right? That's what's a requirement to do the addition, or at least to do it simply. So in order to make that be the case, we need to figure out how to properly scale these fractions to have an equal denominator. And one way of doing that is to use multiplication. I know this is kind of a review of fractions from math class all those years ago, but we're going to, take the numerator of one of the we're going to take the denominator of one of the fractions and multiply it by the numerator and the denominator of the other fraction to scale it up. and then we'll take the original denominator of the other one and multiply it by the numerator and denominator of the other one. And then we also have to make a new fraction. So we don't want to manipulate either of the fractions that we're adding together. That's actually not what we want. We want those to remain intact. We want to create a new fraction that represents the result. So we need to specify what the new numerator and new denominator are. So let's compute those. I'm going to say int new numerator is going to be equal to, and this is where there's some arithmetic involved. It's going to be this dot denominator times the numerator of the other plus the other denominator times the numerator of this. That's how we're scaling up the numerator of the fraction. Sketch it out on paper if you're having a hard time following this in your mind. Just make a simple example like 1/2 plus 3/4 or something. Work through the math. For the denominator, that one's a little bit simpler. It's just going to be this denominator times the other denominator. Okay? And then finally, we need to make a new fraction. So our result we'll plug in the new numerator and the new denominator to our result, and finally we'll return. All right, that was kind of a lot of stuff. Let's test it. I think before we try and do any more stuff, let's test this and make sure it's actually working somewhat appropriately. I'm going to make my main method right down here. Oops. We need two fractions. If we're going to do addition, I need two fractions to add together. And I'm going to try and keep the math, somewhat simple. I'm going to say fraction 1/2 is equal to new fraction with 1/2. And then I'll make a new fraction called 2/3, which is going to be a new fraction to come through. We now want to add these together, and that's going to make yet a new fraction. So I'll add 1/2 to 2/3 by plugging one of those methods in. There's our two fractions being added together. One is a parameter, and one is this. Notice that this one is reciprocal, so we could actually flip these two and still get the same result back out because addition works that way. Finally, we need to print out the result, which I'm going to try and do by just printing out this fraction directly. Let's see what happens. I'm going to run this. All right, so it did run, and here's our result. You can see though that this doesn't really tell us what the answer is. If you remember from class, there's another method that we talked about that's very useful to us called the toString method. I think this is a good time to include one here. We'll just keep it easy. We'll return this dot numerator. We'll put a little slash in this dot denominator. And now that we've defined how this should look when we print it, we will run this again. We see that we get 7/6 is our answer. Let's verify that math real quick. 2/3 would scale up to 4/6, right? 1/2 is going to scale up to 3/6. So 4/6 plus 3/6 is going to get me 7/6 as the result. All right, that's going to do it for addition. Let's take a look at what else we've got. Fraction should be able to multiply itself by another fraction. Okay, let's do multiply next. This one I think is even easier. We don't have to worry about scaling or anything like that. In fact, I think we could do this all in one line. Here's how I might approach this if I was going to do it. I would say this dot numerator times other dot numerator, and then this dot denominator times other dot denominator. It's kind of a long line, but it's getting it all done in one line. This is how we compute the new numerator just by doing multiplication, and this is how we do the new denominator. Let's try it out. Let's multiply our two fractions together and print out the result of that product. I'll say fraction product is equal to 1/2 multiply by 2/3. All right, and then we'll print out that product. Here we go. And if I run this, I get 2/6, which is 1 times 2 over 2 times 3. So 1/2 of 2/3 would be 2/6, or 1/3. So that appears to be working correctly. A fraction should be able to take the reciprocal of itself. So this only involves one fraction, right? I'm not combining two fractions together. I am simply flipping the fraction that I have. So I don't need a parameter for this one. Just need to flip this fraction and then create and return the result. And we can do that in a similar way by putting the denominator in as the numerator and the numerator in as the denominator. Let's go ahead and print out the reciprocal of 2/3 and make sure that that is working properly. There we go, 3/2. And then finally, this might be this might be the trickiest one, although if you know how to do this, it's actually not all that tricky. Fraction should be able to simplify itself, returning a new fraction as that simplification. Now, I'm not going to go through the simplification process in detail, but it does involve figuring out what the greatest common divisor is for both the numerator and the denominator. And hopefully, saying that rung a few bells for you, because Studio 6, which we recently completed, had you do a method for greatest common divisor. We gave you the iterative version. We asked you to write it recursively. I'm actually going to take this. I'm going to copy it into my fraction class so that we can use it here to help us with the simplification. Now notice, this is a static method. Now's a good time to kind of talk about the differences between static methods and the methods that we've been using in this studio, which are non-static. Notice that none of the methods that I've used so far today are static, with the one big exception of main, which is always going to be static. But what's the difference? Again, recall that we're using objects now, and in order to use objects, we have to have instance variables and a constructor that sets them, and then we need to call the constructor to create an instance of a particular object before we are allowed to use these non-static methods upon that object. For static methods, we don't have to do that. We don't have to jump through all those hoops. I can just call the method directly. I don't have to call a constructor. I don't have to create an instance or anything like that. Now, the advantages / disadvantages are that within these non-static methods, I'm allowed to access these instance variables. These are unique to each and every instance of the class that we create. But within static methods, you can't do that. If I try to say this dot numerator within the GCD class, it's gonna complain. It's gonna say, you're not allowed to access these values, right? You cannot use this within a static context. There is no instance. In order to use a static method, we do not have to create an instance. So we cannot use this to refer to the instance upon which this method was called. There is no such instance. It does not exist. All we can do is plug in the values and take the return type. So with all that in mind, let's see if we can construct the simplify real quick. We're going to make a new fraction that is the simplification of this fraction. In order to do that, we need to get the divisor, the greatest common divisor of the numerator and the denominator. So I will make a new variable called divisor, and I will call the GCD method, and I will plug in this dot numerator and this dot denominator. That's going to give me the greatest common divisor. Then all we need to do after that is simply create our new fraction. We're going to divide both the numerator and the denominator by that divisor. Okay? So let's go ahead and test this one out. I'm going to create one more fraction that can be simplified for us. big fraction. It's going to be something like 18 over 24, right? Should very easily be simplified. I think 6 is going to be the biggest, greatest common divisor. Should get us down to 3/4, but let's try it out. Big fraction dot simplify. And hopefully we see that 3/4 come back out. There it is. There it is. All right. That's a fun one. I think that might be my favorite one of the entire studio, actually. But yeah, let's move on to the next object on our to-do list. The next one that we're taking a look at is complex number. So this is going to be more math, more arithmetic that's involved. Complex number has a real part and an imaginary part, each represented as a double. So those are our hasas, those are our instance variables. Let's go ahead and make a class and start piecing this together. Gosh, spelling is really bad. Imaginary number, that's what we're creating next. And it says we have a private double real and private double imaginary. So imaginary numbers have a real part and an imaginary part. Let's create our constructor next. Should not be terribly surprising what I'm going to be doing for this constructor, so I'm going to go through it fairly quickly here so we can get to the good stuff. And now let's take a look at what they want this imaginary number to be able to do. So here's something that'll be useful to us. It says it should be called complex number. Can I change that? I think I actually can change that. Let me refactor this and rename this to complex number. I like that better. All right, great. Notice that it changed the name of the class and the name of the constructor for me. It's very handy. Complex number should be able to add itself, returning the sum, and it should be able to multiply itself. And then they also include this note here. It's usually shown as a plus b times I. Let's do the two-string method first, actually. I think it's going to come in handy for us to make sure that our code is working properly. And we'll print this out in the, we'll return this in the appropriate format. It's going to be this dot real plus, there would be a plus sign in between the real part and the imaginary part, plus this dot imaginary, plus the letter I on the end of it. We'll be able to test this here in just, actually we can test it right now. Why not test it right now? Make our main method. We need to create a complex number. 2 and 3 for the real and imaginary parts respectively, and then if we just print out this, hopefully we see the proper representation. Here we go, 2 plus 3i. Perfect, that looks good. Let's turn our attention to the arithmetic operations that we've been asked to complete. In order to complete the sum, we're going to get another complex number whose real part is the sum of the real parts and whose imaginary part is the sum of the imaginary parts. Similar to the fraction, actually, and so the method is going to feel similar to the fraction as well. The return type is going to be a new complex number, right? We don't want to manipulate the existing complex numbers that we're adding together. And just like before, the two complex numbers that we're adding together are one that we're coming in as the parameter and this complex number, which the add method has been called upon. I think we can go ahead and just return the new complex number and do the sum right here. It's going to be this dot real plus other dot real, followed by this dot imaginary plus other dot imaginary. Let's see what I did here. I made a mistake apparently. Oh, and here's my mistake. These are doubles, and for some reason I made these integers. Whoops. Let me make these the doubles that they're supposed to be and see if that helps. There we go. Let's come down here and try to add some complex numbers together. the reverse of the one that I have, and then I will add them together and print out the results. It should be fairly easy for us to compute and verify in our heads. It should just be 5 for both of them, correct? And there it is. All right, and then the last method I believe that we have to do for this one is multiplication. So you can see it's going to be A plus B times C plus D. Oh yeah, I see. So it's showing us how to do the computations based on the different parts. So you can see we multiply the real parts together, subtract the imaginary parts, and then there's a similar operation for that one. So let's go ahead and piece this together. I might break this one up into chunks just because there's a lot of arithmetic going on, but it does seem pretty straightforward. All right, so I'm going to do the real part first. Double new real is equal to, I'm going to call this the first one and other the second one. So it's going to be this dot real times other dot real minus this dot imaginary times other dot imaginary. Okay, and now we have to do the new imaginary part. And the equation for that is going to be this dot real times other dot imaginary. And that's going to be added to this dot imaginary times other dot real. Finally, we'll take these two values that we've computed and stick them into a new complex number representing the result. And we're now ready to test this out and see if this works. 2 dot multiply 3. All right, we'll multiply these together. If we run this, we're going to get the two real parts added together, 2 times 3 minus 3 times 2, so that's why we get the 0. And then for the other one, we're going to get 2 times 2, which is 4, plus, hold on a second, is that right? Real times other imaginary, so 2 times 2, which is 4, plus 3 times 3, which is 9, and that's where we get the 13 from. So that also appears to be working. All right, one more class to go before we can wrap up this studio. The last object that we ask you to take a look at is the hockey player. So we're going to make a hockey player class. Let's take a look at the description. It says a hockey player has a name and a jersey number. Most players shoot either right or left, but some can shoot either way. A player can be right or left-handed, but shoot either right or left. So we need a way of tracking, how whether players are right-handed or left-handed and which way they shoot. There's a few different ways you could, decide to represent this. I think for me, the first two instance variables are pretty self-explanatory, the name and the jersey number. So we'll make private string name, private int jersey number. Those two seem pretty self-explanatory, but when we get to this part, this is where it gets a little confusing. Most players shoot either right or left, but some can shoot either way, so I don't think a Boolean is good enough. There's actually 3 outcomes for shooting. I can shoot right, left, or both. So Boolean's not going to work. But a player can be right or left-handed. And it's also saying that it's not the same as how they shoot. So we actually are tracking these separately. I have to track whether they can shoot to the right, whether they can shoot to the left, and then also whether they are right or left-handed. So this one, I think, is either you're right-handed or you're left-handed. There is no third option. But for shooting, there is. So the way that I would approach this, and again, this isn't the only way, this is just one way, I would say private Boolean shoot right. And that's true if they can shoot to the right, and false if they can't. Private Boolean shoot left. That's the same thing. True if they can shoot left, false if they can't. So both of these could be true, or one of these could be true. It's also possible that both of these could be false, in which case you're probably not really a hockey player, but most of the configurations we want, one or both of these two would be true, and then I'll make one more Boolean for right-handed. If this is true, they are right-handed. If it's false, then they would be left-handed. Okay? Now that's a lot. That's a lot of instance variables. So when I come down here and I create my hockey player constructor, again, remember, the purpose of a constructor is to make sure that all these instance variables are properly set by the time this is finished. So let me just check the description to make sure that we don't have any other instance variables that we need. I don't think we. Oh, here we go. A player has a certain number of goals and assists he or she has recorded over all games played. All right. Also, a player has a certain number of points, which is the sum of goals and assists. So we can compute points based off of goals and assists. But we need a way of tracking the goals and assists, right? So private int goals, private int assists. These might be able to be half numbers. I'm actually not a huge hockey fan, so I'm not entirely sure if these should actually be doubles, so you could have a half value there. Real hockey players can fix it if they are upset that I chose to make those whole numbers. But pay attention to how I construct, how I set up the parameters for this constructor. I am going to take in a good number of parameters here. You can see I have a lot of instance variables. And I'll also take in a Boolean for right-handed. But I'm actually going to stop here. I'm actually not going to make a parameter for every single instance variable. And here's the reason why. Here's the reason why I'm not going to do that. For the instance variables that I've highlighted here, goals and assists, I would argue that if you create a brand new hockey player for the very first time, these values are known. I don't need to ask you what these values are when you make the hockey player. I know what these values are already. Let me show you what I mean by that. For the instance variables that I have parameters, I'll set them just the way that we have for the other objects as part of this studio. But for the remaining two, goals and assists, I'm going to argue that I know what those values should be. When I first start playing hockey, I have 0 goals. And when I first start playing hockey, I have 0 assists. No goals, no assists. 0 of each. Those are going to go up over time, of course. In fact, I think that's what the rest of this description is talking about, especially this part right here. This object should be able to react when a player completes a game, recording how many goals and assists the player earned in that game. So that's telling us that there should be a method called play game or complete game, right? After a game has been played, this method will be called so that we can record the number of goals and the number of assists that this particular hockey player recorded in that game. And we'll do that by simply updating our instance variables like so. Okay, let's take a look at what else they want us to do for this particular object. Also, a player has a certain number of points, which is the sum of the goals and the assists, and a player has a certain number of games that he or she has played. Well, we aren't actually tracking the number of games right now. That means we need to add another instance variable, but that's okay, we can do that. Private int games played, right? This is also going to start out at 0. Once I create a hockey player for the first time, the number of games played is 0. But every time I complete a game, I should remember to add 1 to the number of games that have been played. Okay, I think we're almost ready to, tweak this to try and create some hockey players and play some games. Let's do the points. A player has a certain number of points, which is the sum of the goals and the assists. So I'll make a method called getPoints, which is simply going to return this.goals plus this.assists. And finally, so we can test this, I'm going to make a toString method. And I'll just have it return, oh, there's a lot of stuff to return here, huh? The name. In fact, there's so much stuff here that I actually don't feel like typing all this out. I did it for the other ones, but for this one, I'm gonna let Eclipse do it. ToString follows a similar pattern. You probably noticed it by watching me do ToString for the other ones. So, it's possible for the computer to do this for you. And if you want Eclipse to create the ToString method for you, you can come in here to the source menu and click on the generate ToString option that's right here. You have to select which instance variables you want to be included in the ToString method. So, you might want to include all of them. I think for a lot of them that may in fact be the case. But I want to, maybe not include these ones. That's okay. I just want to see goals, assists, game played, and their name and jersey number. Again, there's some subjectivity here, right? Here is what gets generated as a result. You can see it looks a little bit different than how I've been doing it. You're welcome to tweak this. If you don't like the way Eclipse generated it for you, you can of course change it to suit your own tastes. But this does save me quite a bit of typing. And now I'm ready to come down here and start making my main method so that I can start creating a hockey player. We have to supply all of these values, right? The name, the jersey, how they shoot. So here we go. My name is Doug. My jersey will be 131. I am definitely right-handed all the way, so that'll be true, false, true, and then I think that's it, right? That's it for my constructor. So let's go ahead and print out our hockey player before we play any games, and then we'll play a game. I'm going to complete a game, and I got 2 goals and 3 assists, right? And we should be able to then print us out again. And see that we have 2 goals and 3 assists. And then let's play another game. This time, maybe I got 10 goals and 12 assists. I'm really good at hockey, right? That's not true. I'm actually really not good at hockey. But we're just going to do some things for testing purposes. And now when I run this, we can take a look at how this object evolves over time. We can see that after it first gets created and printed out, that's this line right here, the jersey number's there, but the goals and assists are set to be 0, and this is also 0. After we play the first game, you can see that the goals and assists go up to 2 and 3. The games played is 1. And then finally, after we do the second game, right, 10 plus 2 gets us 12 goals. 3 plus 12 gets us 15 assists, and I've now played 2 games. It looks like it's tracking these statistics properly. All right, hopefully this was useful to get used to this concept of using objects. We're going to be using objects for the rest of the semester. They're not going away. It's a hugely, hugely important part of computer science, the world of computer science. But that's going to wrap it up for today's studio. Have a great weekend, everybody, and I'll see you in class next week.